my name is Guo Rui. I'm the founder and CEO of Fronka Tech. We provide innovative equipment solutions for nanomaterial scientists. I have always been curious about materials and technology. Since quite young, I'm thinking about the philosophy question death. It's not because I really think like a philologist. It's because I want everyone surrounding me to stay with me forever. So that I was wondering if there's a medicine in the world that can help people to live forever. And my conclusion to this question is that I have to invent by myself. Otherwise, if other people invent this medicine, the price must be high enough so that people like me cannot afford it. So that I read quite a lot and do a lot serial experiment in my mind. How can I invent this medicine? Unfortunately, I didn't make it. When I went to high school, I naturally became good at mathematics, physics, and chemistry. Such subjects help me explore how the world operates with scientific principles. And when I passed the college exam, the decision now become which subject I'm going to spend the next 4 years. And I have to say, at that time, people warn me that biology is a subject that you can hardly find a job after you graduate. People start changing from the 21st century is the century of biology to biology is something you don't want your child to study. So I chose chemistry, and I went to Nanjing University to study 4 years of chemistry. All universities provide different subjects in chemistry, such as organic chemistry, biology chemistry, and physics chemistry. And I think sometimes it's destiny, and I end up with very good supervisor in physics chemistry. I do my final year project at his lab, and he teach me quite a lot on physics chemistry. I then become more interested in the materials and the physical principles behind. After graduation, I was thinking, okay, what shall I do now? I try to figure out what I'm good at and what's my advantage. And this childhood dream came to me again. I realized since young, I always want to be a scientist. This scientist dream is what I really want to pursue. So I went to National University of Singapore to pursue my PhD degree. During my college years, there's this discovery of graphene that won the Nobel Physics Prize, and this magical materials with unimaginable properties initiate worldwide interest in such class of two-dimensional materials. Why we call it two-dimensional materials is because the thickness of such kind of material is just one atomic layer, so that the thickness is so thin that we can ignore the dimension in this thickness dimension, so that we trim down three-dimensional material that is what we see every day, the bulk material, into two-dimensional material. And graphene is the representative of such class of material. And when I went to NUS, my supervisor in NUS, he also works in such kind of two-dimensional materials. And I also found this subject very exciting, and there's a lot of possibilities and novel physics phenomena for us to explore. So I dive into this new class of materials. But doing PhD is really hard. I have to admit, there are a lot of ups and downs. There are a lot of times your experiment just failed, and you cannot explain what you observe. And what really frustrates me is that because we don't have proper tools to study such kind of new materials, my experiment failed again and again. So let me explain more on the investigation I have done. I will use one machine to fabricate the nanostructure with the particular two-dimensional material I'm working on, and then I will use another machine to do the structure modification to change the property so that the property is what we want. And later on, I need to take the sample out to another machine to test the performance so that I know whether I did before is what I want. The problem is, usually these different machines are located in different labs, and I have to take my sample from one lab to another lab to do what I want. I remember at a time we need to collaborate with another lab in Department of Engineering, so that I have to take my sample from Department of Chemistry to Department of Engineering. It's quite near if you take the shuttle bus in US, but unfortunately, when I do like a week or two preparation and did proper work with my sample, and I take the A1 bus to the Department of Engineering, I found out my sample is already oxidized during this process. That's really frustrated me, and I also remember I can't remember how many times I just take my sample and run between different labs, and I even took a taxi. One time I want to test my sample at A-Star, near One North MRT station. So it really frustrates me, and also my lab mates encounter similar problems. That's why we want to develop a proper tool to study this new class of materials. At first, we don't, because all of our background are in science department, in science, so we don't really have too much engineering background to build the machine we imagine. So at first, our simple idea is just to contact external vendor, a machine vendor, so that he can make whatever we ask for. However, we found out the price they charge is very high, and they don't promise the delivery, since they told us there's a lot of experimentation and there will be a lot of trial and error. So they don't really promise us anything, but at the same time charging such a lot. We decided to do it by ourselves. So that's when we started to learn mechanical engineering, electronic engineering, and because we know the materials, so we know what kind of equipment can help us with our investigation of the materials. And you can see here, this is actually our third generation equipment. We already have our first and second generation. The first generation, I would say, is really very bulky, very ugly, and only with a few very simple functions. But eventually we iterate based on our understanding of the materials, and we also do a customer interview with other people working on two-dimensional materials, so that now you can see here for the third generation, although it's still a bit from the industrial standard, but it's already complicated, comprehensive, and with some beautiful design here. As I explained earlier, my previous experiment always failed because I need to take my sample from one machine to another one. This transfer process not only caused damage to my sample, but also there's no real-time feedback when I'm conducting the whole experiment. I only know what happened by the moment I took my sample to do the measurement. So that if anything happened to my sample during these weeks or months preparation, I know nothing about it. This is really a low efficient process. So with the equipment we developed, now we can, this is a one-stop workstation, so that you don't need to transfer a sample from one machine to another. This single equipment, this single workstation can allow you to do a lot of functionality with your sample. For example, you can do some growth, you can do structure fabrication, and at the same time you can do physical property measurement. You can measure the electrical property, optical property, and optoelectrical properties of the sample. You know the real-time feedback when you are conducting the structural engineering, so that this not only protect your sample against the oxidation and exposure to air, but also improve the working efficiency by providing real-time feedback. Because of the benefits of this machine, I managed to avoid the previous failure because of the exposure of sample to air, and also I observed a lot of novel phenomena during the engineering process and published very good journal during my PhD years. And I graduated on 2019 with a few publications as the first author. And at that time, I was still, I think I'm still facing the same problem every PhD will face. That is, do you want to continue in this academia road, or you want to go to industry and find a job there? And I was also struggling with it. On one hand, I feel like I'm still good at doing research. I managed to find out my own way to conduct research and explain the principles behind. On the other hand, I feel like I already stay in university, in college for almost 10 years. So I really, I'm a bit curious about what's really happening outside. What's really happening in the industry, what the industry are looking at. It was very lucky for me at that time. I found out this graduate research innovation program, and since I'm still hesitating what I'm going to do, then I decided to give it a try. It's a 3 months hot housing plus the subsequent supporting, but I can decide at the end of the 3 months that whether I want to continue or not. So I think it's a good opportunity for me to get exposure to the real business world out there. So I talked with my professor. I asked him whether I can bring the technology we developed in university to the GRIP program. At that time, he is also thinking about whether we can make more use of this machine, because at that time, a lot of our collaborators from Singapore and overseas come to us and want to use the machine to do some research. And they all find this machine quite useful and help them do a lot of good research. So my professor also think this GRIP program is a good opportunity for us to explore whether this machine can bring more value to other people like us. And therefore, I apply for GRIP and get involved. This 3 months of hot housing is really, I would say, mind-blowing, because previously I was just a researcher focused on my own research field. I don't really care what's the manufacturer cost, what is the return of investment and other operational things. I just want to build things I think that's interesting or useful. So I got a lot of business training at GRIP. They teach me how to develop business model, how to analyze your customer segment, how to set the pricing, and how to do market validation. And we also conduct a few customer interview at that time to do the market validation. And at the end of the GRIP program, I think we are quite determined that this equipment can bring more benefits to people like me, like my lab mates and other researchers. This machine can make their life easier and bring them more insights when they are doing research. In addition to academia, it's pretty exciting to see industry also keep an eye on the two-dimensional materials. As we all know, Moore's law is coming to the end, and all the big semicon companies in the world, TSMC, Samsung, they are paying attention to such new class of material. This class of new material can replace silicon to fabricate more advanced electronic device that people nowadays cannot imagine. For example, nowadays we have a lot of VR, AR helmet for us to experience the virtual world. However, we all know that we need to wear this very bulky helmet, and there will always be a cable connect to the computer somewhere, so that we can only use AR, VR at a certain room. However, imagine we now have a chip that is powerful enough and light enough for us to make the helmet much lighter, and because the chip inside the helmet is powerful enough, we don't need to connect it to the computer, so that we can really bring AR, VR helmet with us to wherever we want to go. And Grip is also very supportive with our commercial plan, and they decide to invest us to do the commercialization of this equipment. So in addition to the two choice I mentioned before, whether to continue in academia or go to industry, now I have a third choice to do my own startup. I have to say, at first I'm also a bit hesitant and not brave enough to take the step, because I never see myself as an entrepreneur. But I think it's I'm pretty lucky that I got supported from my supervisor, from Grip and other business mentors I have. They encourage me that I can become a very good entrepreneur, because I, with this science background, can better understand what my customer needs in their research, and I can also largely lower down the communication cost we have with the customer. And I'm very lucky that my family is also very supportive. They really encourage me to step out of my comfort zone and to explore what I can really build outside. So that's when I finally made my decision, and Fronka was incorporated in May 2020. There are a few challenges during this transition from a researcher to scientist. I would say one of them is the language barrier. As you can see, I'm not a native speaker, so the language we are using in science and the business are also very different. In science, we need to be very precise with what we describe. But in business, it's another thing. Sometimes we see businessmen are very risky, and they tend to describe something very furtive so that they look confident. But in science, we always be very cautious with the thing we use. We will see about roughly, maybe, but in doing business, you cannot see that, especially when you are entrepreneur, you are building this vision. You must be very confident about what you are doing. You can't see, maybe we can do this, maybe we can do that. There's a possibility. I cannot guarantee things like that. You are the boss. You must be very confident with what you are doing. And also as for the language side, I must say some business vocabulary is quite different from what we use daily. There are English words that I know the meaning of these words, but when they combine together, I don't understand. So it really takes me a lot of time to learn and to learn the meaning first, and then I will use these phrases and expressions in my communication. The second challenge is that as a researcher, you just need to do your research and present the results in an organized and reasonable way. You communicate with your audience about the scientific problem and your explanation or proposal to that. However, as a businessman, or as an entrepreneur, you need to pitch to investors, you need to talk to your customers, or you need to talk with internal, external organizations. So you must be very careful when you are talking with different audience. You need to be very clear what the people of the table expect from you, so that you can tailor the content so that they can understand. The third challenge is that as a researcher, most of the time you are self-motivated. You just need to motivate yourself and you don't have to deal with so much people relationship. However, as an entrepreneur, you need to be not only self-motivated, but also have the ability to motivate others. You need to motivate the investor to invest on you. You need to motivate the customer to buy the product. And also you need to motivate the team to work hard to build the dream. I think I'm still learning to be a person who is good at motivating others. And I personally face another challenge is that to be honest, doing this startup is my first job after my graduation. So I don't have too much experience in the industry or in the business world. Sometimes when I talk with investors or collaborators, they will think I'm too young to talk with. And also I'm a female, so they will expect a experienced senior male person to talk with rather than me looking inexperienced and young. There is a time that I become very troubled by this stereotype image, but I recently realized that being young and inexperienced is not my fault. People can decide how they treat me from my appearance, but eventually what they really buy in is my professional skills and the product we have. And being young also means there are a lot of potential and opportunities ahead. It's just you need to work harder and harder to prove your real value. If there are 2 or more paths ahead, always choose the right one, although sometimes it may look difficult. Learning science and technology will empower you, the logic mind, to understand the working principle of the world. There's a better chance that you can change the world.